Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Coming up on SpaceTime, a small but evolving dent in Earth's magnetic field, the strange hot world of Kelt 9b, and calls for the development of a new satellite early warning system to deal with hypersonic missiles. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists are seeing a split in a growing weak spot in Earth's magnetic field known as the South Atlantic Anomaly. Earth's magnetic field acts like a sort of protective shield around the planet, repelling and trapping charged particles from the Sun and deep space. However, over the southern Atlantic Ocean, an unusually weak spot in the field known as the South Atlantic Anomaly allows these particles, usually high-energy protons, alpha particles and free-flying electrons, to dip closer to Earth's surface than anywhere else. It means the particle radiation can crash through this weak spot in the magnetic field, hitting delicate circuit boards and other electronics aboard spacecraft, damaging or destroying their systems, and even reducing multi-million-dollar satellites into space junk. In order to avoid losing instruments or entire satellites, operators commonly shut down non-essential components as they pass through the anomaly. For example, NASA always turns off key systems whenever the Hubble Space Telescope orbits through. And astronauts flying through the region also suddenly find their laptops crashing and in need of a reboot. The International Space Station, which is in low Earth orbit, also passes through the South Atlantic Anomaly. It's well protected and astronauts there are safe from harm while inside. EVAs, that's NASA speak for spacewalks, are never conducted when the space station is slated to fly through the anomaly. Instruments on the outside of the orbiting outpost are affected by the higher radiation levels. One regular victim is the Global Ecosystem Dynamics Investigation Mission, or GEDI. It collects data directly from various positions on the outside of the space station. And the South Atlantic Anomaly causes regular blips in GEDI's detectors, forcing resets of the instrument's power boards about once a month. NASA's Ionospheric Connection Explorer regularly travels through the anomaly in order to monitor its magnetic field strength and map its position. NASA also studies the particle radiation in the area and around the anomaly using another satellite, the Solar Anomalous and Magnetospheric Particle Explorer, or SAMPEX. Scientists looking at 2 decades of SAMPEX data have shown that the South Atlantic Anomaly is slowly but steadily drifting in a northwesterly direction. The results are helping to confirm models created from geomagnetic measurements showing how the anomaly's location changes as the geomagnetic field evolves. The good news is that currently the South Atlantic Anomaly creates no visible impacts to daily life on the Earth's surface. However, I wouldn't want to be a commercial pilot flying a daily run between South America and Africa. The anomaly is of interest to scientists who monitor changes in the magnetic field strength there, both for how the changes affect the atmosphere and as an indicator for what's happening to Earth's magnetic fields deep inside the planet. NASA's scientists in geomagnetic, geophysics and heliophysics monitor the South Atlantic Anomaly in detail to try and predict future changes in how that will affect both space operations and life on Earth. The anomaly arises from 2 features in Earth's core: the tilt of the magnetic axis and the flow of molten metals within its outer core, some 2,900 kilometres below the surface. The Earth's a bit like a bar magnet, with north and south poles that represent opposing magnetic polarities and invisible magnetic field lines which encircle the planet between them. But unlike a bar magnet, the core magnetic field isn't perfectly aligned through the globe, nor is it perfectly stable. That's because the field originates from Earth's molten iron-rich outer core, which is in constant vigorous motion, spinning around the solid metallic inner core like a geodynamo, generating electric currents, which in turn produce the geomagnetic field. As the core motion changes over time, due to complex geodynamic conditions within the core and at the boundary with the solid mantle above it, the magnetic field tends to fluctuate in both space and time. These dynamical processes in the core ripple outwards into the magnetic field surrounding the planet, generating the South Atlantic Anomaly as well as other features in the near-Earth environment, including the constant tilt and drift of the Earth's magnetic poles. These evolutions in the magnetic field, which happen at similar timescales to the convection of metals in the outer core, provide scientists with new clues to help them unravel the core dynamics that drives the geodynamo. Recent observations and computer modelling suggest the anomaly is both expanding and continuing to weaken in electromagnetic strength. Importantly, and that's what the story's all about, it's also splitting. The data shows the anomaly's valley, or region of minimal field strength, has split into two separate lobes, creating additional challenges for satellite missions. Terry Sabaka from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the magnetic field is actually a superposition of fields from many different current sources. Regions outside the solid Earth also contribute to the observed magnetic field. However, the bulk of the field does come from the core. So the forces in the core and the tilt of the magnetic axis together produce the anomaly, the area of weaker magnetism, allowing charged particles trapped in Earth's magnetic field to dip closer to the surface. The Sun expels a constant outflow of particles and magnetic fields known as the solar wind, as well as vast clouds of plasma and radiation through processes known as coronal mass ejections, literally explosions of stellar material. When this material streams across space and strikes the Earth's magnetosphere, that's the space occupied by Earth's magnetic field, it becomes trapped and is held in donut-shaped belts around the planet, known as the Van Allen radiation belts. These belts restrain the particles, forcing them to travel along the Earth's magnetic field lines, continually bouncing back and forth from pole to pole. The innermost belt usually begins about 640 kilometers above the surface of the planet, and so keeps its particle radiation a healthy distance from the Earth and most satellites in low Earth orbit. However, when an especially strong solar storm of particles reaches the Earth, what scientists refer to as space weather, the Van Allen belts can become highly energized, and the magnetic field can be deformed, allowing charged particles to penetrate deep into the atmosphere. Of course, the other big deal with the South Atlantic Anomaly is that it's also being seen as a potential sign of polarity changes which would affect the entire planet. We know that the Sun flips its poles every 11 years, the so-called solar cycle. The North Pole gets a south polarity and the South Pole gets a north polarity. Well, the same thing on a slower timescale happens with the Earth. Geological records of solidified lava show Earth's magnetic north and south poles have flipped or reversed polarity on average about every 250,000 years. The problem is it's been over 720,000 years since the last flip, so the planet's well and truly overdue for the next. Many scientists are speculating that strange magnetic activity surrounding the South Atlantic Anomaly could be a sign of an impending polarity reversal. Of course, others are debating that it's not. Either way, life on Earth seems to survive these polarity reversals without too many problems. The issue this time, however, is that the next polarity reversal, whenever it happens, will also affect human technology, and man's reliance on that technology means it's a whole new ballgame. We'll keep you informed. This is SpaceTime. Still to come, the strange hot world of Kelt 9b, and calls for the development of a new satellite early warning system. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Astronomers have discovered one of the strangest, most extreme worlds in the galaxy. The planet Colt 9b is a so-called hot Jupiter, basically a gas giant in a very close-in orbit around its host star. And while all hot Jupiters are fairly unusual, this one has set new standards for weirdness. You see, the exoplanet is on a near polar orbit around its host star. Most star systems, including our own, see planets orbiting around the host star's equator, along what we call the ecliptic. But Colt 9b is on a polar orbit. And to complicate matters even further, the host star rotates so quickly, it's distorting its shape. The study's lead author, John Aulers from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says this unusual combination of factors makes it difficult for astronomers to understand the star and its effects on the planet. Colt 9b was discovered back in 2017 by the Colt Transit Survey, a project collecting observations from two robotic telescopes, one located in Arizona, the other in South Africa. The planet was picked up because it passes directly in front, that is, transits its host star for at least part of each orbit. As the planet passes in front of the star as seen from Earth, a small but detectable amount of the star's light is blocked out, causing the star to appear dim at regular intervals. And that's the telltale sign there's a planet there. Colt 9b is a gas giant. It's about 1.8 times bigger than Jupiter, with about 2.9 times Jupiter's mass. It's located some 670 light-years away in the constellation Cygnus the Swan. The planet swings around its host star in just 36 hours on an orbit that carries it almost directly above both the star's poles. Because the orbit's so close, gravitational tidal forces have locked Colt 9b's rotation so that the same side always faces the star. So as you can imagine, things get pretty hot. In fact, Colt 9b receives some 44,000 times more energy from its host star than what the Earth does from the Sun. And this gives the planet a dayside temperature of around 4,300 degrees Celsius, which is actually much hotter than the surfaces of many stars. And this intense heat is causing the planet's atmosphere to stream away into space like a comet's tail. It's all pretty strange. But then again, the host star is also weird. It's about twice the size of our Sun and about 56% hotter. But it rotates on its axis some 38 times faster than the Sun, completing a full rotation in just 16 hours. That compares to our Sun's average rotational speed of 29 Earth days. Now, this rapid rotation distorts the star's shape, flattening it at the poles and expanding its equator. Now, because the surface of the star's poles are now closer to the core than the equator, the poles end up being much hotter and brighter than the cooler, dimmer equatorial region. It's a phenomenon astronomers refer to as gravity darkening. And the result of all this strangeness is a temperature difference across the star's surface of almost 800 degrees Celsius. So with each orbit, the planet Colt 9b experiences the full range of stellar temperatures, producing what amounts to a peculiar seasonal sequence. Let me put it this way. The planet experiences summer when it swings over each hot pole, and then a sort of winter when it passes the star's cooler midsection. So think of it like Colt 9b experiencing 2 summers and 2 winters every year, with each season lasting just 9 hours. Measurements from NASA's Transiting Exoplanet Survey satellite tests have enabled astronomers to greatly improve their understanding of this bizarre environment. Between July 18th and September 11th last year, tests observed 27 transits of Colt 9b, taking measurements every 2 minutes. These observations allowed astronomers to model the system's unusual star and its impact on the planet. The findings, reported in the Astronomical Journal, suggest the varying levels of energy being received by the planet from its host star is likely to produce an extremely dynamic environment. Also, Colt 9b's polar orbit around its flattened star produces distinctly lopsided transits. The planet begins its transit near the star's bright poles, then blocks less and less light as it travels over the star's dimmer equator. This asymmetry provides clues about the temperature and brightness changes across the star's surface, and it permitted the authors to reconstruct the star's out-of-round shape, how it's oriented in space, its range of surface temperatures, and other factors impacting the planet. This report from NASA TV.
Colt 9b. It's about twice the size of Jupiter, and it's always super hot, taking only 36 hours to orbit its star. it receives 44,000 times more energy than the Sun delivers to Earth, making it one of the hottest planets known, with a dayside temperature hotter than the surfaces of some stars. This causes its atmosphere to boil away into space. Now, thanks to observations from NASA's TESS satellite, we know Kelt 9b is even weirder. TESS spots dips in starlight whenever a planet passes in front of its star from our perspective. Astronomers call these dips transits. But Kelt 9b's odd star complicates things. It spins so fast, it's squished into an oval. This makes its poles hotter than its middle, a property scientists call gravity darkening. The planet's orbit, also odd, carries it over the star's poles. Combined, these effects make the start of each transit different from its end, making further study difficult. A team led by NASA Goddard scientists used TESS observations to disentangle these effects and provide further insight into the system. The polar orbit and gravity darkening give Kelt 9b an unusual type of season. Summer occurs when it passes over the star's hot poles. Winter, such as it is, happens when it passes the cooler equator. And for every 36-hour orbit, which is Kelt 9b's year, the planet experiences these seasons twice, and each is less than 9 hours long. Scientists expect the frequently changing temperatures produce wild winds, and they're busy modeling Kelt 9b's atmosphere. Thanks to TESS, astronomers are equipped to learn more about this curious system, and others like it.
The United States and Japan are looking at developing a new satellite-based missile early warning defense system in order to focus on the growing threat to world peace being posed by China and its puppet state, North Korea. The new satellites would complement existing missile defense systems, which include Japan's PAC-3 missile interceptors. The growing urgency follows heightened concerns that Pyongyang has finally miniaturized its nuclear warheads, thereby allowing them to be deployed with their ballistic missile forces. Turkey is also worried about increasingly militant and threatening China. In fact, Beijing's increased its military expenditure by 6.6% from last year alone. The People's Liberation Army already has more than 2,000 intermediate-range ballistic missiles capable of reaching Japanese territory, and it's looking at doubling its nuclear capacity. It's also following Russia's lead in developing a new generation of hypersonic missiles which can defeat existing satellite early warning and intercept systems, thereby seriously impacting the balance of power. Making matters even worse, tensions between Japan and China have been escalating in recent times after Beijing's been placing Chinese vessels near Japan's Senkaku Islands in the East China Sea. This is SpaceTime. Still to come, the launch of a new Argentine Earth Observation satellite. And later in the science report, despite their claims of wokeness, it seems 72% of Generation Z wouldn't eat humanely grown artificial meat. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
SpaceX has launched a new Earth observation satellite for Argentina. The SAOCOM 1B was launched aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Base in Florida. The mission was originally planned to launch out of the Vandenberg Air Force Base in California, but was later switched to the Cape, making it the first sun-synchronous polar orbit launch from Cape Canaveral in more than 50 years. The flight path meant the rocket flew south over the Atlantic Ocean instead of east. The Falcon 9 first-stage booster was on its fourth flight, returning to Florida and successfully touching down on Landing Zone 1.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff of Falcon's first East Coast polar launch, Ola, Argentina.
We're now 40 seconds into flight. Falcon 9 has taken off. It's cleared the tower, and we're currently throttling down to prepare for maximum Q. That's the point of maximum aerodynamic pressure. It's at 1 minute, 12 seconds.
Vehicle is supersonic. Vehicle has reached maximum aerodynamic pressure.
You've heard it. We've reached max Q. At this point, the loads in the vehicle become less and less as the atmosphere gets thinner. We're now able to throttle those Merlin engines back up. And at its maximum power, like right now, the vehicle consumes more than 700 gallons of fuel per second. All is looking good with our first stage's trajectory. The next couple events, there are 5 events, one after another. First, our main engine cuts off on our first stage. The stages will separate. Our first stage will then flip around to begin its landing attempt. The second stage's Merlin vacuum engine will ignite for second engine start 1. The first stage's boost back burn will start. It's one of 3 burns to help us land. They occur one after another in about 15 seconds.
And we have Miko.
Stage separation confirmed.
And ignition.
All right, all of those events happen successfully one after another. This boost back burn, it'll last about 40 seconds. Our second stage carrying those 3 satellites to orbit. And coming up next in about 20 seconds, that boost back burn will end, and then we'll have our fairing deployment.
Stage 1 boost back shutdown.
All right, the boost back burns has successfully ended. Our 2 fairing halves will now jettison to expose the satellites to space. First stage has already been a turnaround, and nitrogen from our attitude control system helping guide it back.
Fairing separation confirmed.
2 fairing halves have jettisoned. It'll take us some time to get those to come back down.
Next milestone for the first stage is its first stage entry burn. Falcon 9 needs to execute an entry burn to slow itself down before hitting the dense parts of the atmosphere. Without this second burn, relying on the atmosphere alone to slow Falcon 9 down would put unnecessary strain on the rocket.
Stage is following nominal trajectory.
Acquisition of signal, South Texas.
We've deployed our 4 hypersonic grip fins. They help to guide the first stage back during descent by moving the center of pressure on the vehicle.
Stage 1 entry burn startup.
And 3 Merlin engines have relit and are currently slowing the first stage down before it hits those dense parts of the atmosphere. Second stage continuing to perform as expected.
Stage 1 entry burn shutdown.
And that is our second burn completed. We are going to be attempting to recover this booster back at land on landing zone 1. The first stage has one more burn left.
Is saved.
That is the landing burn. It begins just before we touch down and provides the booster with a soft descent before we land. During this period, the landing legs will also be deploying right before we touch down. They're stowed at the base of the vehicle and made up of state-of-the-art carbon fiber and aluminum honeycomb.
Stage 1 transonic.
The first stage is passing through the cloud layers right now.
Stage 1 landing burn startup.
And here comes Falcon 9 attempting its landing.
Stage 1 landing leg deploy.
And you could not ask for a better landing than that. Falcon 9 has landed once again. That is number 4 for this first stage booster and the 58th overall of an orbital class rocket. What a way to start off tonight's mission. The second stage and our primary mission are still continuing and remain healthy. The next milestone for the second stage is second engine cutoff 1, also known as SECO 1, and that is coming up at T plus 10 minutes and 5 seconds.
The SAOCOM 1B will now join its sister satellite SAOCOM 1A, which launched back in October 2018. The 3,050-kilogram spacecraft are each equipped with full polarimetric synthetic aperture radar to monitor weather conditions, study soil moisture content, and analyze crop yields from a 620-kilometer high orbit. The mission also carried the GNOMES-1 constellation of small satellites. They're designed to provide radio occultation data for weather forecasting, climate research, and space weather monitoring. Also aboard was the Tyvak 0172 nanosatellite, built by Tyvak Satellite Systems, and whose purpose has remained classified. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study of more than 200,000 men in the United Kingdom has found a link between waist size and prostate cancer. A report to the European International Congress on Obesity found a link between how much body fat men have around their belly and waist and their risk of death from prostate cancer. It seems those in the top 25% for waist circumference were also 35% more likely to die of prostate cancer than men in the bottom 25%. Scientists have discovered a blood test which could help predict those at risk of psychosis. The new test, reported in the Journal of the American Medical Association, looked at proteins in the blood plasma of 12-year-olds, allowing doctors to determine the likely risk of psychosis in those subjects by the age of 18. Researchers compared the blood plasma proteins of people at high risk of psychosis who then went on to develop the condition with a control group of randomly selected people, finding differences in the levels of 35 blood proteins. They then used some of these protein differences to see if they could predict from a group of 12-year-olds in the general population who would go on to develop psychosis by the age of 18. They found that 67% of those who the test predicted were at risk of psychosis did in fact go on to develop the disease, and 75% of those the test predicted not to be at risk remained free of psychosis by age 18. German intelligence has evidence that Iran has actively been seeking technology for weapons of mass destruction and missile carrier systems as recently as last year. The new report adds to a growing list of independent documentation confirming the Islamic Republic's ongoing efforts to develop weapons of mass destruction in violation of its international agreements. The new intelligence reports warn that Iran, Pakistan and to a lesser extent Syria made efforts to procure equipment and know-how for the further development of weapons of mass destruction and their delivery systems. The term delivery system is used to define the capability to launch missiles. The United States and Israel, as well as many Gulf nations, believe Iran's radical Islamic regime is seeking to develop nuclear weapons. That's a claim strongly denied by Tehran, which insists the oil-rich nation's massive nuclear program is for peaceful power generation only. They claim to be the virtue-signalling wokerati of identity politics. Yet there's growing evidence that Generation Z simply don't have the environmental credentials to be Greta Thunberg green. A new study reported in the Journal of the Frontiers of Nutrition has found that despite claiming to have great concern for the environment and animal welfare, 72% of Generation Z weren't ready to accept humanely grown artificial meat. Artificially lab-grown meat is defined as meat produced through in vitro cell cultures of animal cells rather than coming from the bodies of killed animals. The study was carried out by researchers from Curtin University and the University of Sydney. As a cohort of 5 million people born between 1995 and 2015, encompassing some 20% of the Australian population and 2 billion people globally, Generation Z are consumers to be reckoned with. But apparently their level of hypocrisy is something to be reckoned with as well.
How dare you!
And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, CastBox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.